Question number 7. Following three planes P1, P2 and P3 are in FCC unit cells as shown below. Consider the following statement and choose the correct option that follows. Option 1, P1 contains no voids of the three dimensions. P2 contains only the octahedral voids. P3 contains both octahedral and tetrahedral voids. Now, in this entire scenario, we need to take into consideration of these particular planes. So let's speak with respect to the P1 condition over here. So in this particular case of the P1, what we see is in this entire case of P1, it is not possible for this particular plane to have a body center octahedral void. Okay, so P1, it does not contain and body center octahedral void. Right? But on the other hand, it does contain one thing, and that is it is going to contain the tetrahedral voids. Okay, so it contains the tetrahedral void. It contains a tetrahedral void. So therefore, I would say that the P1, the first statement, is actually true. Okay, now let's observe the condition number P2. So in the condition number P2, what we see is this is a plane. This particular plane is the plane which is going to cover up, right, the face of P2 cube. So therefore, when it is covering the face of the P2 cube, what we see is in this particular scenario is that it does not contain any particularly tetrahedral voids. Now, as it does not contain any tetrahedral voids and as it is covering only a face, that means still the body part is remaining. As the body part is remaining, there are very good chances of it having an octahedral voids. So therefore, it contains octahedral voids. Okay, so therefore the P2 condition, that is the point number 2, P2 contains only octahedral voids, is also a true case in this scenario. Okay, so now let's observe the condition number P3. Now when we observe the condition number P3, what we see is that the plane passes over here to the center, just like a diagonal, right? So therefore, when it is passing through the diagonal, there are conditions wherein the octahedral voids are present over the edges. Okay, so therefore here the octahedral voids are present on edge, right? So as it is present on the edge, therefore what we can say is there are going to be 12 edges. Now, every single edge is going to be shared by 4 of them. So therefore, there are going to be 3 octahedral voids, right? So therefore, and when we observe about the tetrahedral voids, they are going to be the 4 tetrahedral voids. So therefore, there are 4 tetrahedral voids and therefore, P3 does contain both of them. So therefore, even this particular condition is true, and then we have the option A, where all the conditions or statements are true.